Okay, so question 1. Express Z in polar form in the form cos theta plus I sin theta, Z equals 1. So we have to remember Z equals 1 is that it's 1 across, okay? So it's going to be just from the origin, we're going to have a distance of 1 across, which will bring it to here. And we can see that this angle here is 0 degrees and the length is 1. So remember, polar form is r cos theta plus I sin theta, r equals 1 and theta equals 0. So what we're going to get is cos 0 plus I sin 0 for part 1. Okay. Part 2 wants me to use the Myers theorem to solve the 4 roots of the equation Z4 minus 1 equals 0. Z4 means 4 answers, okay? So part 2 would have Z4 minus 1 equals 0. We're going to bring over the 1, so we're going to get Z equals 1. Now, we're going to change 1 into is going to be cos 0 plus I sin 0. Now there's another thing we have to do here. We have to adjust the angles so that see, remember, angles repeat themselves every 360 degrees. So what you would have remembered in the past was basically when you have 0 straight away, but when you rotate through 360 degrees you end back at 0, and it's constantly repeating itself every single time you rotate. So what we have to add into the angle is rotations, where it's going to be 0 plus 360n. That's going to be plus I sin 0 plus 360n. It's basically just cos 360n plus I sin 360n, where n starts off at 0 and works its way up. Now, next thing we're going to use is the Myers theorem to find the roots of this equation, or the roots of Z squared equals minus 1. So we're going to say bring the 4 over to your side and it becomes the power of a quarter. So it's going to be cos 360n plus I sin 360n to the power of 1/4. Now to the power of a quarter means that we're going to multiply the angle by a quarter. So when you multiply the angle by a quarter, you're going to end up with cos 90n plus I sin 90n. And what you have here is you got to put down your different numbers. You have to start off with n equals 0. So that means Z1 equals cos 0 plus I sin 0. Z2 is when n equals 1. And when n equals 1, it's going to be cos 90 plus I sin 90. When n equals 2, it's going to be Z3, which is going to be cos. Now replace n with 2, you're going to get 180 plus I sin 180. And then Z4 finally is going to be cos 270 plus I sin 270. You need to put that into the calculator and see what you get. You're going to get 1, you're going to get 0 plus 1i. You're then going to get, for this one, you're going to get minus 1 plus 0i, and then finally the last one, when you put it in, you're going to get 0 minus 1i. And this one is technically 1 plus 0i. Now, what I ask next is find 1 minus Z1, 1 minus Z2, 1 minus Z3, and multiply them all by each other. Okay? Now the first root is 1. Okay, so what this means here is that if 1 is the first root, this is 1. So this means that I just have to rename my values. Okay, so this one is actually called Z1 in the question. So Z1, Z2, Z3. Now the only reason I know that is because it says in the order, if 1, Z1, Z2, Z3 are the roots. Okay, so what we're going to do is 1 minus Z1, 1 minus Z2, and 1 minus Z3. 1 minus Z1, 1 minus Z2, 1 minus Z3. Figure out what it is. So 1 minus Z1 is going to be 1 minus I. 1 minus Z2 is going to be 1 minus, now Z2 is minus minus 1. And then the next one's going to be 1 minus Z3, which is 1 minus I, 1I, close bracket. Now we're going to get 2 from this one here. This one here is going to be 1 minus I, and the other one here is going to be 1 plus I. Multiply the two of these out by each other, and you're going to get 2 times 1 plus I minus I squared. The plus i's cancel, leaving minus 1, so it's going to be 2 times 1 minus 1, and that's going to be 2 multiplied by 2, which equals 4. Okay, so that's that one done. Now, next one, number 3. Express minus 8i in the form cos cos theta or sin theta, r into cos theta plus I sin theta, where I squared equals minus 1. So once again, we're going to draw our graph, and this time it's 8 downwards. Okay, because that's the I-axis, that's minus 8i. So what we see is the R value equals 8. The angle is going to be 270 degrees. So this number is going to be 8 times cos 270 plus I sin 270. Now, use the Myers theorem to find the 3 roots. So 3 answers, because it's Z3 of Z plus 8i equals 0. Z cubed plus 8i equals 0. So move the 8i over to your side, and what we're going to get is Z cubed equals minus 8i. We're going to replace 8i with this number here. Now remember, we got to add in our 360n to include all the rotations. Once again, the rotations means if I have a complex number here, the first time it reaches this value is at 270 degrees, but it can reach this value again another 360 degrees later and continues around. So this 360n is going to be added in here. So it's going to be Z cubed equals minus 8i, as discussed earlier. It's the same thing as this complex number here, except we're going to put in the 360n. So it's going to be 8 times cos 270 plus 360n plus I sin 270 plus 360n. Okay, so what we have next is this here. Now we're going to do Z cubed. We're going to bring the 3 over to your side, and this affects it in the following way. When we bring this 3 over to your side, what it's going to do is the 3 will disappear, and it's going to be to the power of a third. Now this a third affects the R value, so it's going to be 8 to the power of a third, and then we're going to have to do cos. We're going to have to divide each of these by 3. So these angles are all going to get divided by 3, so it's going to be 90 plus 120n, and then it's going to be plus I sin 90 plus 120n, and then 8 to the power of a third in the calculator is 2. So this is our new function here. Now, like last time, we're going to start off, we'll call it Z0 this time, okay? So we start off with Z0 when n equals 0. So we're going to have 2 times, when n is 0, we're going to talk about that being cos 90 plus I sin 90. When n equals 1, it's going to be 2 times cos 210 plus I sin 210. And then finally, when Z2 equals, it'd be 2. Now when n equals 2, it's going to be 240 plus 90, which is cos 330 plus I sin 330. And then finally Z3 is when n equals 3. Now remember, we're only expecting 3 answers, okay? So we're expecting Z0 and Z3 to be a repeat of each other. Okay? So it's going to be cos 450 plus I sine 450. So we're just going to put this into the calculator and multiply them all out. And what we're going to get is, first of all, 0 plus 2i. After that, we're going to get minus root 3 minus I. The one after that will be root 3 minus I. Finally, the one after that will be 0 plus 2i. And we can see that these two are a repeat of each other, which means we've completed one full cycle. So our answer for the 3 roots are these ones here. Okay. Now, hence write down 3 roots of the equation z minus I cubed equals minus 8i. So I have to figure out what z minus I to the power of 3 equals minus 8i is. Now, these 3 answers here are a result of this equation here. This equation is the same equation as z cubed equals minus 8i. Look at a comparison between the two of these. They both have minus 8i, and one of them has z minus I cubed while the other one has z cubed. So the only difference is we can use the old answers for z. So the old answers being 0 plus 2i. What's the other one? It's going to be minus root 3 minus I, and then the other one being root 3 minus I. Now these are answers for z, but remember z has been replaced with z minus I. So what we do this time is we replace, instead of z, we write down z minus I, because it's a new equation. And now we're going to bring I over the other side. And we're going to get a z equals 0 plus 3i. And then we're going to get z equals minus root 3, just minus root 3 because the i's will cancel. And then the last one's going to be z equals plus root 3. And there's our 3 answers there. Okay. Next one after that is question 5. Express 2 minus 2 root 3 in the form r cos theta plus I sine theta. So what we're going to do is we're going to draw, once again, just draw our axis. Now we're going to go for 2 across, which is here, and then minus 2 root 3 down, which is going to be around here. And then we can draw our value here. Now we have to find out the r value. The r value equals the modulus, which is the square root of real plus imaginary and both of them squared. So r equals 2 squared plus minus 2 root 3 squared. Put that all into the calculator, and what you're going to get is you're going to get 16, and square root of 16 equals 4. R equals 4. Now we're going to do a full 360, and we're going to try and find out what is this angle x here. Angle x, tan x, is 2 root 3 over 2. X therefore equals tan inverse 2 root 3 over 2. Put that in and we get 60 degrees. Okay, so now we know that that is 60 degrees. We know that this one here will therefore have to be 300, because it has to all add up to 360 degrees. So r is now going to be, it's going to be 4 cos 300 plus I sine 300. Okay, so that's all of this here, no longer needed. Okay, now the next thing it's going to ask us for is find the 2 roots being z squared of this here. So we're going to move the 2 and the 2 root 3 over the other side, and we're going to get z squared equals 2 minus 2 root 3 I. Now this is very similar to what we have here. We're going to enter in the polar version. Now please once again remember that the polar version, we're going to put an adjustment onto it. the adjustment is once again going to take into consideration the rotations involved in the angle, that the rotation will complete itself over and over again. So we're going to change the angle. So it's still going to be 4. This is going to get changed into 4. And remember, it's going to be cos 300 plus 360n plus I sine 300 plus 360n. Okay? So, what we're going to get here is we're going to use the Myers theorem and bring the 2 over the other side. When we bring the 2 over the other side, what we're going to have instead is it's going to be all to the power of a half. Okay? Then the half affects the 4, so it's going to be 4 to the power of a half, and then it's going to be cos. Now once again, the half multiplies the angle using the Myers theorem, so it's going to be 150 plus 180n. And then that's going to be I sine 150 plus 180n. And then this here changes. So what we're going to get here is going to be 4. Now, that's what z equals. Now we have to find the roots, so we're going to start off with z0. Z0 is going to be 4 cos 150 plus I sine 150, because 180 times 0 is 0. The next one, Z1 is going to be 4 times cos 330 plus I sine 330. Okay, and finally Z2 is going to be 4 cos it's going to be plus another 180, so that is going to make it 180 plus this is 510 plus I sine 510. Now I already know straight away that these two, there's only 2 roots in this equation, so it's going to be Z0 and Z1. Z2 is going to be a copy of Z0, so they're the same thing, so we'll find out for sure now. So oh, sorry guys, one other thing. It was 4 to the power of a half, which made it 2. So I just sort of left that out there. 2, 2, 2. Excuse me. So I'm going to multiply everything in. Each one is going to get multiplied out. And what we're going to get is minus root 3 plus I. And the other one here is going to be root 3 minus I, and then the next one here will be minus root 3 plus I again. So we see they're repeated, so these are our 2 roots here and here. Okay, and that is question 5 done. Now, question 6. Express minus 8 root 3i in the form r cos theta plus I sine theta.